So let's look at example number 1 that deals with inelastic collisions that occur along one dimension, let's say the x-axis. So let's begin. An explosion inside an object breaks the object into two pieces. Now one of the pieces has a mass of 3 times as much as the second piece. Suppose 8,000 joules of energy was released when our explosion took place. Now we want to find the kinetic energy of each piece. So let's see exactly what happens with this object. Suppose our initial object of some mass m is right here, and an explosion takes place, and the object splits into two pieces. One object goes in this direction, the second object goes along the x-axis in the opposite direction. So the object splits in such a way that one of the pieces has a mass of 3 times as much as the second piece. So if this object is composed of 4 markers, like it is, and each marker is composed of mass m, that means this piece has a mass of m, and this piece, since it's composed of 3 markers, it has a mass of 3m. Now, what are we trying to find? Well, initially, our object was at rest. Its velocity was 0. Then an explosion took place. 8,000 joules of energy was released, and that energy was transformed into kinetic energy of this object and the kinetic energy of this object. And we want to find what exactly is the kinetic energy of this object and what the kinetic energy of the second piece is, knowing that the mass of this piece is 3 times the mass of this piece. So let's begin by first recalling that whenever we talk about inelastic collisions, there is a conservation of momentum. And that means we get the following formula. So, if this object has a mass of m1 plus m2, where m1 is m and m2 is 3m, so our total is 4m, then our object will split into mass m and mass 3m. So our initial momentum on this side is 0. Why? Well, because our initial velocity is 0, right? We said our initial object is at rest, and then it splits into 2 pieces, and then this gains some velocity, let's say v1 prime, and this gains a second velocity, let's say v2 prime, where m2 is the mass of this guy, so m2 is 3m, and m1 is the mass of this guy, object 1 or piece 1, which is simply m. So, now let's equate this whole guy to 0, and let's plug in our m for m1 and 3m for m2. And we get the following equation. So 0 equals m times v1 prime plus 3m times v2 prime, where v1 prime is the velocity of this guy and v2 prime is the velocity of this guy. So now we basically want to find what the ratio of our velocity is. So what's the ratio of the velocity of object 1 to the velocity of object 2? And the way we do it is simply we divide both sides by m to get rid of the m's, and then we simply solve for v1 prime divided by v2 prime. And we find that the ratio of their velocities is -3 over 1. What that basically means is that the negative means these guys are going in the opposite directions. And what the 3 means is that this guy's velocity is 3 times as high as this guy's velocity. And that makes sense because the mass of this guy is 3 times as much as the mass of this guy. So because this guy is lighter, he will have a greater velocity. So, velocity of object 1 is 3 times that of object 2 and points in the opposite direction. So, let's suppose that if the velocity of object 2 is v, that means the velocity of object 1 must be -3v. It's 3 times as high and points in the opposite direction. So, now let's jump to step 2. Remember, we said initially the explosion creates 8,000 joules of work, of energy, and all that energy goes into the kinetic energy of our final system. So that's exactly what we write here. 8,000 joules of energy is released, and that equals the kinetic energy of my system, where 1/2 m1 v1 prime squared is the kinetic energy of this guy, and 1/2 m2 v2 prime squared is the kinetic energy of this guy. So let's now plug in what m1 is and m2 is. So we know that m1 is simply m, and m2 is simply 3m. So let's plug those in, and let's also plug in what the v1 prime and v2 prime is. We said that v1 prime is negative 3v, and v2 prime is simply v. So let's plug those guys in. So notice that now I have in parentheses negative 3v squared. So let's square this and let's see what we get. 8,000 joules is equal to 9, because negative 3 squared is 9. So 9mv squared divided by 2 plus 3mv squared divided by 2 equals 8,000 joules. So notice what happens now. Well, this is the kinetic energy of my object number 1, and this is the kinetic energy of my object number 2. And notice that the kinetic energy of object number 1 is 3 times as high as the kinetic energy of object number 2. And that means if I want to find each individual kinetic energy, I have to represent them as the following algebraic equation, where my x simply represents the kinetic energy of this object, and 3x, since it's 3 times as large as the kinetic energy of this object, represents the kinetic energy of my first piece, the lighter piece, the faster piece. And I find 3x plus x equals 4x, and x must be 2,000. So the kinetic energy of this object traveling faster and it's lighter is 6,000 joules, while the kinetic energy of the heavier object represents 2,000 joules.